All right, so this is Git, Just the Tips. I am Jared Grip. I work for Change.org. You can find out more about me at those two addresses. I should warn you, this is not a beginner Git talk. This is sort of advanced to semi-advanced tips that I have accumulated over the years that I find useful in my daily usage of Git. If you're still like a weekend hobbyist or you're a beginner, I highly recommend Scott Chacon's talk. So I'm just going to sort of shotgun fire through a bunch of tips. I'm going to go pretty quick. So a lot of the stuff that we're going to go through is Git configuration stuff, and so it's helpful to know that Git has at least two main configuration files. There's one in every clone of a repository that's in the .git/config, and then there's one optional in your home directory. And these just house any number of options and variables that can change the default behavior of just about every Git command that can be useful. First things first, the best thing ever, color. Out of the box, I've seen in some cases Git does not come with color options, so you don't get, you just get black and white text, and it's a lot harder to read. So if you add this to your Git config, you can totally turn its lame output into awesome output. Highly recommend that. Git bash completion is awesome. Also, I don't think comes just basic install. If you follow that link and just download that file and source it when your shell loads, you get bash completion, which is super nice. It completes a whole slew of stuff. It'll complete all the Git commands. It'll complete all your branches. So it just sort of makes git, checkout, origin master super easy to type. These are just some of my basic Git aliases. Sorry about the word wrap. The ones at the top I feel like are pretty canonical. Just sort of, I think I see everyone using those, but you'll need to know them if you're not familiar with them to sort of watch me go through some of these examples. Mainly I'll use ST for status and CI for check-in, CO for checkout. Fixup is a cool little alias where oftentimes you'll put together a commit, you'll commit it, you'll realize that you have one other change that you forgot to add to that commit. You just want to make a quick amendment. Fixup, if you just add that change to your index and you get fixup, it'll just shove that right onto the last commit and redo that last commit with the same commit message. Git log, GitL is just a sort of prettier, shorter, more terse log version, and you'll see that as I go through some of these examples. And then these are just sort of aliases to sort of get flat lists for files in different states. If you want to use some bash foo to maybe delete all the untracked files or whatever, I've found those useful. Git diff -- word diff is pretty useful. By default, diff will just show you the difference between one line and another line. And this will allow you to see the difference between words. So let me So actually I should back up. I have this sample this sample Git repository that's just a book with a bunch of text in it. I used text for a book just so that there wasn't code in your face to sort of distract you from the things that I'm talking about. So it's just a bunch of text as we're going through some of these exercises. So right now it looks like this, and it's got a little bit of history. In fact, I'm going to reset it back to just going to put me back to where I was before. So we've just got a couple of commits for this simple, small Git repository. So if I go through, and let's say we're editing this and we just want to make some small spelling fixes. Let's just say we found a couple of things, we're making a few changes. If we do git diff, we're going to see that these full lines are changed. If we do git diff -- word diff, you get this nifty output where you see the smaller changes. And I found this to be, in a code context, rarely useful, but sometimes you have some long lines and you want to really dial down and see what the smaller changes are. So that can be cool. Git add patch is probably the most used in my workflow, most used tip that I'm going to have in here today. It's pretty cool. Most Git beginners that I see, you know, I should have kept those. They'll go through and they'll make some changes to a bunch of different files. And they'll just say, okay, excuse me, the changes I've made are good. I'm just going to git add everything and git add everything, and then just like get check in, whatever. Or maybe they'll do like check in -a, and just sort of, you know, make some changes, commit something, make some changes, commit something. What git add patch lets you do is you go through, make a bunch of changes, and then pick apart those changes and commit parts of the overall difference that you have. So we have these changes here in these files, and we're going to do git add -p, or you can do -- patch, and it's going to present you with each change individually, and it's going to give you this prompt asking you to enter in one of these things. And so the main ones that I'm going to talk about are Y and N for basically yes and no, stage this hunk or not, and then split is also a useful one that I'll go over. So let's say we've got, you know, we'll say yes to this change and no to this change and yes to this change. If we look at our status, we're going to have the changes we said yes to in our index ready to be committed, and the changes we said no to not. Yep.
How do you see that list of what each of those letters are?
When you do git add patch, if you just hit enter, it puts it at the top. I don't know if there's like a help or, yeah, that looks like that works. Like H for help. Or question mark seems to work too. The question was, can you stage hunks line by line? So let me show you an example of how you would do that. So let's go and say we want to we're going to change each one of these 3 lines. I don't think it's going to let you do line by line with split, but one thing you could do, let's say I change this line and then a subsequent, like every other line. I think if they're not together, you can hit split, and it's going to split them. So as you can see, it first asks me, it thinks this is one change because they're close together. If you do split, it's going to say, okay, I know that you want this one line, so you can say yes, no, and you're going to get like every other line. But apparently, I think if they're right butted up next to each other, if split doesn't want to break it apart. Another cool thing that you can do is when it's asking you whether you want to stage this hunk, you actually have the option to edit the hunk. And so there's a difference now between like what's in head and what's on the file system. And if you hit edit, it's going to show you that diff. So this is the patch. And you can actually come in here and modify the patch in this file, save it, close it, and that modified version of the patch is what's going to get applied to your index. Hopefully that's clear. So when we do get status, again, we have those partial commits there. So I use that every day. I find it super useful, especially when I find it allows me to sort of get it allows me to do the individual task that I'm planning on, you know, I'm modifying something, I'm planning on doing something, I'm planning on putting this commit together, and if I pause or if I see some other part of the code that I need to change, I don't need to worry about like remembering that. I could just make that change, and then when I go do add patch, I can see that, oh yeah, I made this fix that's unrelated. I'm not going to stage that hunk now. I'm going to do it in a separate commit. So I feel like it helps get out of my way a little bit. Fix whitespace is a setting that you can apply either globally, as you see here, or per Git repository. And what this will tell Git to do is anytime Git takes a patch and applies it, like you're doing when you do git add patch, if it sees trailing whitespace, it will ignore that trailing whitespace and give you a warning. So I don't have this enabled now, but if I enable this, well here, I'll do a whitespace example first. So let's just kill these changes. And so let's say I went into the file and I made this change, and then I also happened to put let's say I deleted all this, and I also happen to put a bunch of white space at the end of this line. So if we do a git diff, you're going to see that change with the white space. If I were to do git add patch now, that white space is going to get committed into my commit. If I add this setting, and you do git add patch, It shows you the same output. You say yes, and you'll see this warning here, trailing white space. You'll also notice that I now have a partial commit of that line. If you look at what is staged, you'll see get diff, the dash dash cache shows me what's in the modified staged area, and that's my change that I intended, and then the diff without it is that white space. So I work in Ruby, I don't like to have white space at the end of my file, so I like to turn this setting on so that if I accidentally forget to like wipe all the trailing white space in my editor, as I go through, I have this last catch-all. So when you're in this position, you can either commit or not, but you can use the opposite of the opposite of add patch, which is checkout patch. So add patch is going to take changes from your working files and add it to the index to stage them for getting committed. And checkout patch is going to remove those changes from the files. It's actually going to modify the files. So if I do get checkout -p, it's that same interface, except now yes stands for discard this hunk from the working tree, and no means leave it there. So yes means I don't want this change. I'm going to destructively throw it away. And so now I'm left with just that thing I intended to commit. Excuse me. Does that make sense?
Yeah.
Great. That's cool. Yeah, absolutely. If you're absolutely sure that you never, ever, ever want to commit white space, then you could totally do a commit hook that would strip that out for you. Should I go through like a demo of like the difference between get pull and get pull dash dash rebase? I guess. Yeah. Okay. Great. Cool. I'm sorry? Yeah. I know how to do it. Okay, so we've got our origin master branches at the same as where our master is now. So I'm just going to reset hard back, if I knew where my mouse was, back to 2 commits ago. And so if we look at our timeline, and that's that alias I showed earlier, it just shows the long version of the commits, and it just includes all the other branches. So you'll see that what we have checked out now, oh, sorry, we are on a topic branch. Let's get rid of that. Cool, so let's get reset hard back to this SHA. So now you see that we have checked out master, and we're 2 behind what's on the remote server. So if we were to do get pull now, Git would see that those 2 SHAs are fast forwardable, and it would just put those right on top. This is generally what happens. If we were to find ourselves in a state where we made some changes, and we added those changes and committed, so here's our new timeline. We've now forked in a different direction from where our origin server is. What's going to happen when we want to pull down these changes is Git's going to do a merge of what was on origin master and what we had, and it's going to create this new merge commit. So this is what we had, what we made, and this is what was on our remote server, and it just merged them together. And by default, that's what Git does, because I'm assuming because merging is non-destructive, it's not going to destroy your old SHAs, it's just going to give you a new one. There's another way to do this, so I'm going to reset back to where we were before I pulled. So now we're back to where we were. If we do get rebase, or get pull dash dash rebase, what's it's going to tell Git to do is take off this commit, then put these commits on, and then put this commit on top of those. So if we look at that, we now have a nice clean timeline where the modification we made, which was previously on top of this commit, has been severed and now put on top of the new history that we've pulled down. That's another like technique that some people use and some people don't. If you want to keep if you want to maintain the fact that you had a branch and you want to keep that expressed in the history of your application, then you would, maybe you rebase, maybe you don't, but you would use a merge. Some people like to have their topic branches rebased off of master and then just stuck right on top so that their history is just nice and straight. I prefer that preference, which is why I have this as a tip in my talk, is that these are two configurations that you can add to your personal setup that will just tell Git that when you do get pull, that it's going to do a rebase by default. Just because, oftentimes, when you're working with side by side with a large team, stuff's going on master all the time maybe, and so if you're pulling down all the time, what you're going to end up with is you're going to end up with a line that's just like merge to master, merge to origin master, merge to origin master, over and over and over, rather than seeing just like a nice clean progression of an order of which those commits came. So unfortunately, you have to do this in 2 stages. Git does not have a way that I know of, a setting that I know of to turn this on globally. It's a per branch basis. So maybe I should back up if people aren't familiar with git config. Git config is a command that is going to modify one of those 2 files I spoke of earlier. So you're going to see your .git/config file. They basically have these sections, and then it's just sort of a variable name and a value. So if I were to do this initial command here, sorry about that. What this is saying git config, and it's going to say branch.master, and then whatever I want and whatever the value is. So if I set that to true, if I show this file, now that setting is there. You can actually just go edit this file and add it yourself. So whether you prefer editing files or using the command line, both are available to you. So again, rebase true is on a per branch basis, and so for every branch that you want get pull to do rebase by default, you're going to have to add this. The only thing that makes that nicer is this setting that tells Git, when it makes a new branch, to automatically set up this option for you. So for any of your pre-existing branches, you're going to have to go and do that command, replacing master with whatever their branch name was. And then if you add auto setup rebase, it'll do it for any of the new branches, if this is the kind of style of polling that you like. This I like a lot. So by default, when you have made local changes to branches and you have remote repositories like GitHub or whatever, when you say git push, Git is going to look at all of your local branches and all of your remote repositories, find any branches that have equivalent names or any branches that have tracking to a remote branch, and it's going to push them all. So if you're working on a specific branch, you say git push, you might accidentally push, if you don't know that this is the default behavior, push changes from another branch that maybe you're not ready to push. So I like to be a little safer, and setting this configuration variable basically says when I say git push, just do it for the branch that I'm in only if tracking is set up. And it puts a little safety barrier kind of in front of you. So I like to have that setting. This is something I found that has like sped up my frequency at which I rebase off of master. The canonical way and the way I always did it was, you're on your topic branch, you want to rebase off master to suck in the changes of the evolution of the app that you're working on. You check out master, you get pull, then you check out your branch again, and then you rebase off master. And this is great when you want to make sure that your local master branch is up to date, which usually you want if you're ready to pull your topic branch into master. But if maybe you're in a longer lived branch and you just want to suck in the changes, you're not ready to push it to master, you can do this nice one-liner where this basically says, sync myself to my remote repositories, git fetch, which is done by git pull. So you're just saying like sync me to origin. What's up? It doesn't merge. It doesn't do any merging at all. It just pulls down the data that you don't have from your remote repositories. Updating your local origin master that is kept at the same state as the master branch on the origin server or remote repository, and then you rebase off that branch. So you don't have to modify your local copy of master if you just want to do like a quick rebase off of where your team's master is.
So you're on the topic branch in this case?
Yes, so you would start here on the topic branch, yeah.
But that means that your local master branch is out of date.
Potentially out of date, totally. Yeah.
It doesn't touch the master branch, right?
This second command here does not affect your master branch at all. The first the first example here, and the way most people do it, is really doing two local branches. You're going to another local branch called master, you're updating it, and then you're choosing, so you're saying, I want my local master to look like origin master, and then you're saying, I want to rebase my topic branch off my local master. I in some cases find it useful to sort of cut out the middleman of my local master branch and just straight rebase off origin master. So if that seems useful and you want to do that a lot, this could help. Git blame-c is super cool. It allows you to blame the editor of a line, not the mover of a line. So often when you're refactoring or whatever, you find a need to, like, you have a huge file, you break it out into 3 files, you move some code. When you make that commit of the moving of that code, and then you blame those files, whoever moved the code is now the person who gets blamed for having written that code. I don't know when you would ever want that. Generally, I think you want this option, which tells blame to ignore line moves and just go back to the last time that line was modified, and it'll show you the original author. So you can feel free, knowing that this is in your tool belt, to go move code around, refactor things, and when people are going to be or want to blame and figure out who wrote that code, they won't come to you just because you moved it. This is an example workflow that I've found useful in spiking out, either spiking new ideas or just, getting Git out of the way and just using it to its full potential, using its like really cheap branches and its really cheap committing abilities to allow me to make quick edits and then go back and use things like git add patch to sort of curate finalized, polished commits. And basically usually how it works, and I'll just get ourselves back to where we were before. Cool, so I will just, I'll make myself a branch. And let's say I'm just like, I'm spiking stuff out. I'm just figuring things out. I'm going around the code base, and I'm maybe adding some code. And let's say I go somewhere and I'm like, oh no, this is terrible. And I find something here, and I feel free to like fix the bug, right? Let's just say I found something and I fixed it, but it has nothing to do with what I'm working on. It's totally unrelated, but I'm still going around and I'm just doing whatever. Maybe I'm running tests. Now I've gotten to a point where like I'm still spiking out this idea, but my tests are green. I'm thinking about refactoring it, and I don't want to worry about polishing my idea right now. I just want to save everything. So I'm just like gonna just check in a whip commit, and I'm gonna keep going. And I'm just gonna like maybe refactor some of the stuff that I did before and just make a bunch of changes. And I'm going to just keep going and keep making just these little save points. I call them whips because they're like work in progress. It doesn't matter what you call them, but I just go through and I just keep making commits. And I found this useful where when you're spiking things out, that oftentimes you want to like save something that you're about to change so that you can go, oh, that was a horrible idea, and just roll it right back without having to pause and like name a commit and like polish things for other people. I just do this for like maybe at an hour at a time. I'll just go through and I'll just have like a really sloppy tree where I'm committing stuff that's uncommented that I wouldn't ever let anyone else see. And then when I'm done, I look at my log and I go, okay, I've gotten this thing working. It's a pretty solid idea. I'm ready to like tweeze it out into these maybe 2 ideas or 3 ideas that I've been working on. So I find the last good commit. I do git reset. Not hard, I just do git reset by itself. And what that does is it just drops those commits, but it leaves my changes. So now I'm left with like the bulk of the things that I'm working on for the last hour. Then I'll just go through and do git add patch, and I'll just do yes, I want this one. Maybe this is part of a thing, and this is not, and this is not, and this is part of a thing, and oh, that was that bug fix, so I'm not going to commit that. This was part of it, that wasn't, right? I'm just going through and I'm tweezing this out, and I'll just put like, idea 1 or whatever that was, and we'll go through and this was my second idea. Oh, that was that bug. This was my second idea, or whatever. We'll check that in. And then the last thing I have is that bug. So I'll like git check in dash m bug fix, right? So now you see like this is my history. So right off the bat, like maybe I'm just spiking something out, but that bug fix I found that needs to go into master. So I'm gonna just check out master real quick, and I'm gonna just cherry pick this SHA right here. So now if we look at my master branch, I've just moved that right onto master. So now I check out my topic branch again. And if we look at the timeline, that would give us a better idea. So here's where everything is. So there's origin master. Here's master. It's got that bug fix. And then here's my two ideas plus that bug fix. So what we can do is we can just say get rebase master. And master is going to put, or that rebase is going to put these 3 commits on top of that commit. And what you'll notice is I don't have that bug fix anymore in my topic branch, because the fact that I've been rebased on top of that bug fix means that having that same commit in my topic branch now makes no difference, and so that commit just gets dropped. So that's an easy way to just going through the motions. You're just changing stuff. You find a bug, you make a commit out of it, and you just suck it right into master. So now I've got these like 2 ideas. Maybe I make a couple more commits of stuff that I'm working on. Right. And maybe I find something that really has something to do with idea 1, right? So this change that I just made right here, I'll sometimes commit things with just squash, and I'll put the SHA, or maybe I'll just put the name like idea 1 or whatever. So now I've got these 4 commits, and so now I'll use my favorite thing in Git, which is Git rebase interactive. Probably the coolest part about Git. Basically, what rebase by itself will do is it'll take a group of commits and it'll take their base, or the parent of that group, and it'll put it on a different parent. In this case, we're going to be rebasing off the same exact parent. We're just going to be using the interactive functionality to make some modifications to that. But basically what Git's going to be doing in this command that I'm about to do is it's going to take these 4 SHAs, it's going to sever them from this guy, and it's going to put this one on and then this one on. It's going to put them on in order, and we're going to make some changes to that. So what you do is you find the commit you want to sever from, and you do git rebase -i for interactive, and you give it that commit, and it's going to open a text file. And it's a little weird when you first see it because it's in reverse order, because we have like our latest head at the top, and then in this file we have our head at the bottom. So that's a little weird. But what it allows you to do is the following commands. It allows you to modify what it has here and change this to something else. So let's say we wanted to move these. So the less intuitive thing is that you can just reorder these commits however you want. So if I have something else, maybe I want that to go first, and this I put this, I wanted to modify this commit with that. So I'm going to squash these guys together. So I can use either, oh my god, where's my mouse? I can use either squash or fix up. They're pretty much the same. Squash will take two and it will just combine them together, and during the rebase process it'll pause and it'll let you modify the commit message. If you just do fix up, you're just going to take the bottom commit, stick an F next to it, and it's going to take this commit and it's going to stick it inside the commit above it. So you make modifications to this text file configuring how the rebase is going to work. You save it, you close it, and then git, oh, that's funny, I have a git conflict. So it's going to go through and it's going to rebase these things. It's going to pause like it did here when you have a conflict. So I'm going to edit this file. It's not part of the plan. And you can see here that I just have a conflict of which I will just, resolve in some not so interesting way. And so you then add that file and you say git rebase -- continue. It's asking me if I want to change the commit message. I'm just going to leave it the same. I should not have edited the same file a bunch.
Realistic exercise.
What'd you say?
Realistic exercise.
Yeah, exactly. Far too realistic. Right? Cool. So resolve that. So we add that file once we've fixed it. And get rebase -- continue. And now if you look at our log, we've now reordered the commits. We've got something else first. That idea got squashed, or that other commit got squashed into idea 1, and we have idea 2. So that's another tool in the tool belt for just sort of like not worrying about your commit history, not worrying about your commits in general, just committing stuff, getting Git out of the way, and then when you're ready to push this up to team members by pushing it to the origin server or show it to anyone, you can reorder commits and change their commit message or do what you need to polish things together. It's worth noting that if you do a rebase, you can see back here, this was our original log file. Sorry, there's so much scroll buffer, you can't really see, but trust me that these SHAs are now different. It has taken those original commits and changed, modified some of them so they now have different SHAs. So you've done a semi-destructive action here in that your original commits are now not connected here anymore and will get cleaned up by Git's garbage collection. So if you made this mistake and you want to go back and you did a rebase and you're like, oh no, I screwed it up and I want to go back, you can just go back to get the SHA where you were before of your previous head, and you can just do git reset hard, and now you're back to where you were before. So again, I think Git uses merge by default in a lot of cases because rebase does destructive actions like this. You can't. It's not always easy to get things back if you don't write down what the SHAs were that you're worried about losing. You can go into things like the ref log and get them back, but when you're using rebase, it's helpful to know that you should be keeping copies of these SHAs if you're unsure and you want to get back to them. The rest of these are just some tips for working with teams. Some of the stuff that we use here that we found super useful and that I've used at other companies. We do a lot of pairing, and so one of the tools that we use that's pretty invaluable is Hitch. If you haven't heard of it, it utilizes one of the features of Git that by default in your global configuration file, you'll have your author name and your author email address and all of your commits get that information. You can overwrite that temporarily by setting environment variables, and Hitch utilizes that to allow you to do things like you can see in my PS1 here, I've got me, and you can look at the logs, and it's getting committed as Jared, and then it's engineers plus Jared. If I do Hitch, Jared, and Steve, it'll say it's Jared and Steve, and if I were to do a commit message, it would be committed as the pair that was working on the task. So if you work somewhere where you do pairing, it's a nice way to see that these 2 people are responsible for this change, or these 3 people or whatever.
Do you have your PS1 published somewhere?
The PS1 was actually, I'll show it to you. It's actually kind of crazy. So that thing I talked about earlier that does the bash completion will provide you with this little method that you can use in your, pretty sure it's in that file. Maybe not. I don't know. I can publish it with these slides. But basically, it provides you with a bash function that you can put into your PS1 that every time it gets set will export things like the name of your branch. So when you check out master, it's pretty easy to know what branch you're on at all times. That's super helpful too. Another thing that's cool that I read about on Miss Love's blog, which is a super interesting utilization of the git config. Basically, like we talked about earlier, git config will write to these configuration files. So if we look at our .git config file, you can actually write whatever you want to this. So if you write git config branch .master .foo bar, and then you don't pass bar, it's going to give you back whatever option you passed in, and it's just going to store it. And Git doesn't use that, but it's just available to you. So what this allows you to do is save metadata about particular branches. So if we wanted to say that, like, on this topic branch, foo was Baz, when we say we're going to get back, when if we know the branch that we're on, we can actually query these configuration files and get back metadata. So what he's done is come up with a way to where this is for in a Rails context, in your database YAML, he just has some code here that gets your current branch name, and then looks in your configuration file using that current branch to figure out if you've set this option to true. If you have, it modifies the database name. So why this is useful, it's really cool. Why this is useful is if you check out a topic branch and you're heavily modifying a schema and you need to go back to another branch that has a significantly different schema, it takes time to schema load and maybe repopulate your database. So what you can do is you check out your topic branch, you set this configuration, and then you recreate your database, and now when you switch branches, it just seamlessly jumps from one database to another.
So does that configuration setting get passed with each commit, or is it?
No, it's actually not stored in Git's save everything at all. It's just written directly into this file.
But that file is not, you don't.
This is not version controlled, no. Yeah. So if you were to clone this somewhere else, you would not have the same, right? So it's actually cool to, like, if you take this concept, you can explode it out to, if you're using other data stores or any other configuration needs, or even outside of a Rails context, you can do some pretty nifty stuff with these per branch variables. That's it. If you want some even more advanced Git tips, I recommend another Scotchcone talk where he goes into some crazy stuff that you can do with Git, some super advanced, crazy, weird things that are pretty interesting and a fun watch. I highly recommend it. The question was, do I have a particular workflow? I guess any tips for a workflow of when I'm forking another person's project and changing it and then doing a pull request?
Yeah, and also like some of them might never actually make it into the main branch, the main fork. So like, how do you manage that? If it's never going to get taken and I plan on maintaining my own fork, other than just branching it on GitHub and maintaining my own copy of that, I don't have anything that I think is unique in that. If you have a more specific question, I can try. Well, I guess, because then you're diverging, right, completely, and it may be harder for you to merge the new changes of that back in. So
right. One thing that you can do is you can add the other, so if you fork it on GitHub, you've got your own copy. Maybe your origin in your local checkout is your copy on GitHub. You can add another remote as the original project. So if I fork jQuery, I can have my own copy. So origin is my copy, and then maybe I name another remote like upstream or whatever, right? And so now I can do like get pull origin master or get rebase upstream master, and so now I have these two different like remote repositories, which are just sets of branches that I can rebase from and merge to and manage that relationship that way. So what he just said was, if he forks a project, he will make a branch where he's making all his crazy changes, and then he'll make another branch where he'll cherry pick out the reasonable things that he wants to get pulled or wants to put into a pull request. Since on GitHub pull requests are per branch, he'll curate that branch that he's preparing as a pull request and keep maybe some other crazier stuff in his personal branch. That is a very good point. What he said is it's important to note that since Git Rebase Interactive, or just Rebase in general, is potentially going to take commits and change their parent
and therefore change the SHA of that commit. If you're on master and you've pushed already, and those SHAs exist on master, you can't modify those and push those, because just by practice, everyone has agreed that the master branch doesn't get modified. So if you pushed it up, it's there to stay. And so you would need to be careful of how you rebase. The example I gave didn't violate that, but I could see how it would be easy to do that. So yeah, sorry, he asked, have you ever thought about using pre-commit hooks to run your tests? I've never worked on a project, not never, but most of the time I'm working on a project where the test suite takes long enough to where if I hit commit, I don't want to wait even if it was 40 seconds, I wouldn't want to wait that amount of time just to make sure the commit was there. I feel like commits should be light and mutable and just a tool that you can use as often as possible. So
You could probably do it every time you push too.
you could definitely do a pre-push hook.
Running a
That's not a bad idea at all, actually. Yeah. All right, well, thanks very much, guys.